Although physics is an exact science, but the measurement of physical quantities are never exact. The difference between the measured value and the correct value is known as errors in the measurement. Now we have two types of errors. One is systematic error, other is random error. Systematic errors, the reason are known to us, why this error is happening, why it is not giving us the correct result. So there are many reasons for systematic error. And other type of error is random error. The reasons are not unknown. There are many possibilities for which these errors are coming. So we use statistics to eliminate such error. Now, systematic error. The errors which occur in an experiment in a systematic manner are known as systematic error. Since the cause of errors as well as the numerical values of error both are known before handling that measurement, hence it can be corrected easily. The simple reasons are, suppose imperfect scale. Suppose you are given with a scale having 97 up to the mark of say 97 centimeter, and with this scale you are measuring 1 meter. So you know that every 1 meter measurement with this faulty scale will introduce an error of 3 centimeter. Means whenever you will measure with this scale, you will measure 3 centimeter less. So suppose you have to measure 3 meter, so you will have to add 9 centimeter, because each measurement will introduce an error of 3 centimeter. So because of the imperfect scale, it is known in advance that how much correction needs to be done to make it perfect, so it can be corrected. Imperfect instrument. The zero error in a screw gauge. If you use the screw gauge, you find that in a screw gauge what happens, this type of instrument to use the to find out the diameter. So normally what happens, this scale, main scale and circular scale reading should coincide when it is 0, but we find that the tip touches this thing, and instead of 0 it is something else. So in case it is not 0 at the beginning, you know in advance that what is the value on the scale. Okay, so that correction can be made. So in a screw gauge, the because of this imperfect instrument, this 0 error calculated in advance, and later on this is applied to make it correct. Imperfect setting of a scale. Suppose there is a circular scale, so voltmeter or ammeter or any circular scale, we have a pointer here. Okay, so ideally speaking, when no current is passing through this instrument, then the 0 of this scale should coincide with the pointer head. But sometimes because of the faulty setting of this scale, we find that it is not here but somewhere here. Say suppose it has covered 3 mark, so it means that it has a 0 error. So because the instrument is basically the scale is not perfect. So similarly, or we can find out that suppose it is instead of 0 it is here. Okay, so if after passing current this pointer reaches up to this point, so it means that it has introduced this much error, because it should ideally start from 0, the pointer should start from 0. So because of the imperfect setting of the scale, systematic error introduced, and it can be corrected. Now random error. Suppose we are finding the time period of a pendulum. Now say suppose we find the time period, means suppose it starts from here, it goes to this extreme end and again comes back to it. So using the stopwatch we are finding this time. Each time we measure this with a very sensitive stopwatch, we find this time period is different. The reason of this error may be we are not in sync. The moment it starts its motion, we are not starting the stopwatch, or the moment it stops its motion here, we are not stopping it, or there may be there may be a delta, there may be a difference with our ocular observation when we are seeing this and starting this stopwatch. So our reaction of starting the watch is not coinciding with the actual event of this pendulum. So this type of errors causes random error. Now we use statistics to minimize or eliminate such error. So what happens, in order to find out the exact time period, we will repeat this interval. Say we will measure it 10 times. So suppose first measurement gives the value x1, second measurement gives the value x2. Similarly it is repeated up to n times. 10 times we are repeating. Then if we divide this by the number of observations made, this gives the mean time period. So we can conclude that the mean of all this observation will at least gives the near values of time period. Deviation. The first deviation, suppose mean is x bar, so the first observation has a deviation from the mean. This is the mean minus the first observation. Similarly, deviation from the second for the second observation is mean minus the actual observation reading. Similarly, delta 2 will be x bar minus x2 x2. This is delta 3 will be the deviation of the third observation, mean minus the actual reading in the third observation. So we can easily find out that if we sum up all the deviations, it will become 0. Now mean deviation. Now when suppose mean deviation is represented by a, now let us consider the mode of all the deviation, means we will consider only the positive sign. As we know that if we add up delta 1, delta 2, delta 3, the total sum of all the deviations will become 0. Now so we are taking the mode of delta 1, only the positive values of deviations are taken. Delta 3, delta n. Now suppose this is n. So this gives the mean deviation. Now actual result in terms of mean deviation, actual result is the mean plus or minus whatever it is the deviation. Similarly, in statistics we use standard deviation. Standard deviation is denoted by sigma. It is square root of all the observations which we are making, summation of observation of this all the mean deviations, square I equal to 0 to number of observations by n minus 1. So the actual result, correct result is, result after calculating it through standard deviation is, this is mean plus or minus, this is the standard deviation.